Okay, so we've got this question here. It says given that log p log b base p equals x and log b base q equals y, expressed in terms of x and y, log b pq squared, log b p over q cubed, log b is the square root of b p squared over q. Right. So colleagues, here this is just a matter of applying the laws of logarithms. All right. We need to simplify these expressions. The purpose of this question is these expressions here for a, b, and c, we need to express them in terms of x and y. Okay. So we're going to apply these laws of logarithms here to answer this question here. So we start with part A. Okay, so part A, let me even do it near the logs here. Part A is saying log B open brackets PQ squared. Okay, so we need to simplify this. So we're going to apply the product rule, which is rule number one. Have you seen? Log b m times n equals log b m plus log b n. So if we look at our question here, all right, it's similar to this. Okay, log b m multiplied by n. Okay, here it's log b p multiplied by q squared. So we can break this down to become log b p plus log b q squared. Okay, colleagues, here I've just applied this first rule here. Okay, I'm simplifying this expression. So this expression, if we apply the product rule number one here, it becomes log b p plus log b q squared. Okay, then we're not yet done simplifying. Okay, because this q squared, we need to get rid of this root here. This is where we're going to apply rule number three here, the power rule. Okay, have you seen log b m to the power k equals, this k is just going to come in front of the logarithm. Have you seen? K log b m. So that's the same thing that's going to happen here. This 2 is just going to come in front here. So our expression is now going to read log b p plus 2 log b q. Okay, these questions which we're still is just all about applying the laws of logarithm. Okay, yeah, just showing how the laws of logarithms work. All right. Then in our question, they told us log p equals x, log bq equals y. So it's just a matter of substitution. Okay, it's just a matter of substitution. So log bp, we substitute it with x, plus 2, then log bq equals y. So that is our answer here. Okay, colleagues, any questions? So the secret of these questions is just knowing the rules of the logarithms. Okay, that's the only context here. You just need to know the rules of the logarithms to apply them to simplify things. Okay, yes. Any questions before we move to B? Okay, we go to part B, which is saying log B P over Q cubed. Okay, log B P over Q cubed. So for this one here, colleagues, as you can see, we're applying rule number 2, quotient rule. Okay, you have seen the format log B P over Q cubed. Here you have seen log B M over N. Okay, so whenever you're dividing these things, when you're applying the quotient rule where there are two terms being divided, it breaks down into this log B M minus log B N. Okay, so we're going to apply this rule here in this same question here. Okay, so it's going to become log B P minus log B Q cubed. Okay, we've applied the quotient rule. Then we're not yet done. Remember, whenever there's an exponent, a power, then we apply the power rule here, where the exponent goes in front of the logarithm. So this 3 is going to come in front here. So we're going to have now log B P minus 3 log B Q. Okay, so we're going to say log BP. Remember, according to the question, they told us log BP equals X and log BQ equals Y. So this becomes now X minus 3Y. Okay. As I said, the secret to these questions is you are applying the rules, the laws of the logarithms. That's all that's happening here. We're just applying the laws of logarithms. Okay. Yes. Any questions? Are there any questions? Because remember, after this, I'm going to give you some practice questions using these logarithms. Okay, C log B, the square root of B P squared over Q. So here we're going to apply many rules here. Okay, we're going to apply many rules here. Okay, so first, what we're going to do is we need to separate this expression inside here. Okay. Since there are three terms here, what we need to do is we need to isolate one term by itself so that we make life easy. Okay, colleagues? We need to isolate one term by itself. So since there is a root here, this root here, and there is a p squared here, so what it should tell you is the p squared should be isolated by itself. So meaning this should be best simplified to log b square root of b over q multiplied by the square root over p squared. Okay, here I haven't applied any rules of logarithms. Okay, I haven't applied any rules of logarithms. I'm just separating this expression here so that this p squared is by itself. Okay, colleagues? So that the p squared is by itself. All right, so now it's log b square root of b over q multiplied by square root of p squared. Okay, so no rule has been applied yet of logarithms. Okay, then we're going to say log b square root of b over q multiplied by the square root of p squared is p. Okay, the square root of p squared is p. All right, now we can start applying the laws of the logarithms. We're going to start with the product rule. Okay, the product rule, remember we're multiplying this root of b over q times p. All right, so we can apply the product rule, which becomes like this: log b square root of b over q plus log bp. Okay, first we can apply the product rule. All right, then after we apply the product rule, we still need to handle this one here. We still need to handle this one because this log bp has already been simplified, so we don't need to do any more operations with it. But it's this one here, this log b square root of b over q, that we need to simplify further. Okay, so we're going to say log b. So this square root is the same as to the power half. So say log b over q raised to the power half. Colleagues, this is a law of indices. Okay, this law a to the power m over n is the same as the root of n a to the power m. This is the law of indices that I've applied here. Okay, so if it's a to the power half like this, it's the same as just writing the square root of a. That's what I've applied here. Okay, this is a law of indices. All right, this root we've converted it into this power half. Okay, colleagues, so here then laws of indices will apply. So I'll also share with you the laws of indices. Okay, then we're still not yet done with this log b over q to the power half. Okay, we are still not yet done with it. So when we apply the power rule for logarithms, this one here, we have to bring the power in front there, in front of the logarithm. So in this case, this power half is coming in front. Okay, so we're going to have half log b over q plus log b p. Okay. Then we're still not yet done here because the here this is where most of the operations are happening. When it's still not yet done now. Now we can apply the quotient rule here. Everything this is b over q, so we can apply the quotient rule. So it becomes half open brackets log b b minus log b q plus log b p. Okay. Then have you seen this log b b? Here's another row of indices. Where is this one? If you see a logarithm like this, log b b, it gets a 1. It equals to 1, okay? Or for example, if let me use numbers. You see log 5 5 like this, a situation like this, just equate it to 1. Okay, so this rule here, we're applying this rule here, rule number 5. Okay, so that becomes half open brackets 1 minus, and according to our question, log bq equals y plus log bp equals x. So this is our answer. Okay, if you want, you can expand the brackets. You can say half times 1, that is half. Okay, half times negative y, that is negative half y plus x. Yes.